Okay, good morning everyone. In this video, I'm going to prove square root of 7 is not rational. I'm going to use proof by contradiction for this proof. And thank you very much for coming to another video of Cat Can Code. Let's get started. So for proof by contradiction, we always start with assuming the opposite of what we need to prove, which means square root of 7 is rational. We assume this. So for proof by contradiction, we normally use this assumption to our advantage to deduce some sort of contradiction so that we can conclude that our assumption is wrong, which means the opposite is right, which means square root of 7 is not rational. So let's try to deduce a contradiction from this assumption. So now we can utilize this assumption as well to our advantage. So because of that assumption, we're gonna have square root of 7 can be written as a divided by b, where a and b are two integer numbers, b is different from 0, and the greatest common divisor of a and b is 1. Assuming that the greatest common divisor of a and b is not 1, for example, a number like 3 or 6, whatever, then we can divide both a and b to that common divisor that is not 1. And then we will end up with two numbers, m and n, that has the greatest common divisor that is 1. So we always can get to the point that square root of 7, if it is rational, it can be written in the form of a divided by b, where a and b has the greatest common divisor of 1. Okay, so now we establish that based on assumption, we will have this information. So we're gonna use this. So we're gonna try to square both sides of this equation. Then we will end up with a square divided by b square. And this can be written as 7 times b square equal to a square. So it means 7 divide a square, right? When 7 divide a square, we can say that 7 also divide a. So there are a few ways to go from this 7 divide a square to 7 divide a. One technique is use prime factorization, because 7 divide a square, then 7 will be part of the prime factorization of a square. But we know that a square is just a times a, which means 7 will be part of the prime factorization of a as well. Therefore, 7 divides a. Another way to prove it without using prime factorization is using another contradiction here. So to prove 7 divide a, we assume that 7 not divide a. We assume the opposite. So when 7 not divide a, there are 6 situations. So either a equal to 7m plus 1, or a equal to 7m plus 2, or a equal to 7m plus 6. So all the way from 1 to 6. When 7 is not dividing a, it means when you take a and you divide by 7, the remainder will be either 1 to 6. So for each of these cases, you need to prove that what happening. You need to prove a contradiction. So a square, you just square both sides, and it will end up with 7m square plus 2 times 7m times 1 plus 1 square. So now you will end up with the value of a square that cannot be divided by 7. But you know that 7 divides 8 squared. Therefore, it is a contradiction. And similarly, you can prove the contradiction for all of the other cases. Overall, our assumption that 7 is not dividing 8 is wrong, which means 7 is dividing 8 because of the mini proof by contradiction here inside the main proof by contradiction over there. All right, so now we have established that in either methods we can prove that 7 divides 8. Therefore, A can be written as 7 times M. So we substitute this into this equation, then we will have 7 times B squared equal to 7M squared. It means 7 times B squared equal to 49 times M squared. We divide both sides by 7, then we'll have B squared equal to 7 times M squared. Because of this equation, we can do a similar proof, right? We can do a similar proof and we can say now 7 divide B squared. But we have established that if 7 divide the square of a number, then 7 also divide that number. Similar proof. We can perform either using the prime factorization argument, or we can use another mini proof by contradiction inside. So similarly, we can say 7 divides B. We also have 7 divide A. Now suddenly 7 is a common divisor of A and B because of this line and this line. Okay, but we know that the greatest common divisor of A and B is 1 based on our assumption. This leads to a contradiction. Because of this contradiction, then suddenly we have both. We have our assumption here, initial assumption here is wrong, which means the opposite of that is right. Therefore, is square root of 7 is not rational. Okay, so we have proved that square root of 7 is not rational using proof by contradiction. Thank you very much for watching, everyone. And I hope to see you in the next useful video. Take care. Goodbye.